Hello, my name is Benjamin Deniston with the LaRouche Political Action Committee Scientific Research Team. And I am here today. I'm very happy to be joined with Professor Sergey Pulinets, speaking to us from Moscow over Google Hangouts for a very special interview discussion on the subject of technologies that can be used to control weather and increase rainfall to help address the drought and water crises going on in places like California, other places in the United States, but also other places around the world. Obviously, this is a very important issue now, given the water shortage in the western United States, but also globally. So we're very happy to be joined here to be able to discuss some new technologies, new frontier ideas that can help mankind manage the atmospheric resources, the water resources of the sky, potentially, and begin to give mankind potentially an ability to increase rainfall where it is needed and secure the water supplies for various regions. Now, Professor Pulinets has some important background and familiarity with these technologies and some of the theories behind how these technologies work to allow mankind to stimulate rainfall with ionization systems. Professor Pulinets has been involved with a company in the United States called Rain on Request, which is promoting the utilization of these technologies in the United States. He's also written on the subject, including an article that was published in Russia Beyond the Headlines in 2009, entitled "Weather Control, Yes, It Is Really Possible." Earlier, Professor Pulinets had worked as part of a team assessing the validity and the scientific basis for some of these weather control systems in Mexico in the late 90s and the early 2000s. So, again, I'm very happy to be joined with Mr. Pulinets today. This, I think, is going to be a very useful and helpful discussion for this current water situation. And to start off, I would like to ask you, Mr. Pulinets, because clearly this issue is met with a lot of skepticism. If you bring this up, a lot of people have a very quick reaction to just dismiss the idea that we can control these things such as weather processes, rainfall. But you have done work actually assessing the scientific basis for some of these systems that have been operational for many years, and which have been reported to show success in increasing rainfall in Mexico. So I was hoping we could just start by hearing about the history of your familiarity with these systems and your understanding of where they've worked and how well they've been successful so far.
Hello, Ben. Hello to everybody. I would like to clarify a little bit the situation. Actually, my background, it is a space physics.
Mm-hmm.
And starting from the end of 19th, we started to learn about the effects in the ionosphere which are associated with the earthquakes. It was very interesting how the information from the ground, that even underground, penetrates to our space, and I started to develop the theory about this. And to do this, I should be involved into geophysics, in the solid geophysics, what happens before the earthquakes. And for the first time, I encountered the problem of the ionization, which is created by the radon emanating from the Earth's crust and increase of this emanation before the earthquakes. Radon can produce the ionization of air near the ground surface, and then this heat is propagating up to the upper layers of atmosphere, up to the tropopause. Another thing, it is effects of the cosmic rays. Probably you know that the clouds which cover our planet in great extent are formed due to galactic cosmic rays, which produce the ionization. And then the ions becomes the centers of water vapor condensation and nucleation and formation of drops and clouds, which we see every day. And there is correlation between the cloud coverage of our planet and the variations of the fluxes of the cosmic rays. So nature gives us the answer that ionization can produce the nucleation. We have these examples from space, galactic cosmic rays, and from the ground, from the natural radioactivity. And we can see, for example, the results of studies of Japanese scientists who, through the discharge from the needle, created the flux of the ions and put them in the mass spectrometer, and were able to see how grow the particles. And if you look at the picture, you will see the distance between the sequential spectrum lines. In atomic mass, it is 18. It is the atomic mass of the water molecule. And you see how ions gains more and more and more water molecules, and it was proved experimentally. So this, let's say, the theoretical background, how the ionization can produce the large clusters, where in center we have the ion and the envelope from the water molecules. I came to Mexico and was working in the Institute of Geophysics of UNAM. You know, it is the greatest university in Mexico City. Working in the problem of the earthquakes. But there I met some friends who may be familiar with some Mexican company named ELAT, which made the experiments with the stimulation of the rains. They had the contracts with the governments of different states, especially in the drought areas of Mexico, so in Sonora Desert, to produce the rains to increase the harvest in these areas. And it is very interesting that the main idea and maybe ideology was proposed also by Russian scientist Lev Pokhmelnikov, who was the founder of this company and was supported by Mexican businessmen and primarily by the mayor of Mexico City. And because the physical mechanism is the same, simply the sources of ionization are different. We have radon before the earthquakes, and they have a special installation which produces the artificial ionization. So we started to cooperate, and I was familiar with their results. Actually, I can provide you some pictures with their results, and they are very impressive. And after that, I became the member of the scientific committee, where represented the representatives of the Mexican Meteorological Agency, scientists working in the physics of atmosphere. There was one scientist from United States. I can give you the list of the scientists who involved in this committee, who had the purpose to estimate if the effects produced by this company are real. And I participated in several meetings of this committee where we discussed the results. So what is the how looks this installation? It is a high mast near 30 meters, from which, like rays, the very thin wires go. Why very thin? We know that if we take the needle, for example, before the thunderstorms, when we have the higher voltage, high electric field in atmosphere, we sometimes can see the discharge from the needle. So now let us imagine that we have the ends of needle connected in the thin wire, and the smaller diameter of this wire, the more effective you can glow the coronal discharge, putting the higher electrical voltage on this wire. So you create something like umbrella from this mast, and you have peripheral shorter mast, and you have this installation and put the higher voltage, which produce ionization of air. And then if you have put positive or negative potential on this installation, with this electric field, for example, if you put positive potential, so the positive ion will be moved by the electric field up to the upper layers. And moving to the upper layers, they gain more and more water molecules and become the nucleus to form the clouds. Actually, for example, we can see even these effects before earthquakes, when the linear clouds are formed over the tectonic faults. And this effect is observed everywhere and reported by many scientists. This is the same effect by the electric field. The ions produced by the ionization by radon go up and form the linear clouds over the active tectonic fault. Two words. This is an explanation of this technology. Of course, it is stands the physics behind this, but I should underline one very important thing. We know the technology of so-called cloud seeding. When from airplane you disperse, for example, silver iodine, or even you can disperse the cement. Because any dust or aerosols in air become the center of condensation, and you stimulate the precipitation of rain. But the difference between these two technologies is following. By seeding, you can precipitate only this water which already exists in air, and you cannot create nothing more. And here you create the new nucleus, and you take the water vapor and collect it into the drops. And if you put your installation near the seashore, for example, in California, you can very easily to put this installation near the shore. You can collect the humidity and then transport it, because you can put the different potentials between two installations. It creates the movement of this air filled by the this nucleus for formation of clouds inland. So actually, if we are now speaking on the technology, you can take the water from ocean to move it inland and then create the precipitation. But to create precipitation, you should create some conditions, relationships between the temperature in the altitude of clouds and dew temperature. So you should have your temperature lower than dew temperature to condensate and create the drops and create such kind of instability which in nature we have in the thunderstorms. Actually, all the people and sometimes physicists of atmosphere are thinking in the terms of the hydrodynamics. For example, describing the typhoons, hurricanes. They look only at the hydrodynamics, mechanical movement, but they forget that we are living in the electrical world. There is huge electric potential on the top of the hurricane. We live in the constant electric field which exists between the ionosphere and ground. The potential difference between the ionosphere and ground is near 250 kilovolts, and sometimes it can gain 400, 500 kilovolts. And on the ground surface, the vertical gradient of the electric field is 100 or 150 volts per meter. So you are a tall guy, so between your legs and head, you have 200 volts, the potential difference all the time. So this potential difference is created by thunderstorm activity globally. So thunderstorm activity charges the ionosphere positively in relation to the Earth, and in areas of fair weather, we have the return fair weather current, which is very low, but nevertheless we have the closed electric circuit, which is called in science global electric circuit. And simply we use everything what is given for us by nature, helping a little bit with this ionization to create the additional centers of nucleation. Now it exists the direction in science which is named ion-induced nucleation, this effect, which is explosive nucleation in presence the source of the ionization. So you can produce these centers of condensation, and your task to transport it to the altitude of clouds formation and then create the conditions to precipitate this.
Just to clarify for our audience here, so I think just to maybe take a couple steps back, you're saying, so we start with the fact that there's, on the one side, there's already a lot of water vapor, evaporated water in the atmosphere. So on the one side, with these ionization systems, you can create the conditions which accelerate or increase the rate at which that water, that evaporated water, condenses and forms liquid droplets, which can help
In the initial state, it is not droplets yet, but nucleation centers.
Uh-huh.
Yes, they are very small to call them droplets. It is a complex process from the ion to larger particle to the ion cluster, then nucleation, and then the droplet.
And you had said
The same process as formation of the clouds in natural conditions. Simply you form it near the ground surface and then transport them up with electric field.
and you had said that Japanese scientists have done experiments demonstrating the role of increased ionization in facilitating this process.
Yes, yes, they published several papers, and I can provide you these publications with the figures showing how these particles grow, and it is very interesting. And I should also underline that contrary to the pure condensation, which needs the saturated water vapor, 100% humidity, pure water to have condensation. This process is called ions hydration, attachment of the water molecules to the ion, and you can see from their pictures that this process takes place in any level of the relative humidity. Even you have humidity 25%, you still will have the formation of these ion clusters with attached water molecules. Of course, the larger humidity, the more effective process is we have. The larger particles are formed. But in general, hydration takes place in any level of humidity.
Mm-hmm. And then
so, even in low humidity conditions, you can create the large particles and precipitate them in the form of dew, for example. And for the plants, it is doesn't matter if you have rain or you have dew; they can gain the water even from dew.
Then you had also said, so that's in addition to helping to induce what atmospheric moisture is there to come down, either to precipitate or to come form as dew, you can also induce more flows of moisture to come in from over the ocean. You can actually increase the water availability in the atmosphere too.
Yes, and I provided you the pictures from the Mexican experiments. You see the line of installations perpendicular to the shore, starting from the Pacific, and this line helped to move the mass of the air filled with the humidity inland of the Mexico.
And so you had said, based on your work, these systems in Mexico have shown some pretty impressive results.
Yes, you can see there the results of filling on dams of the hydroelectric power plants. And there was 3 dams, and there are results for 1.5 years, and you can see how these dams were filled up with this knowledge. Actually, they also tried to fight with forest fires in the Yucatan Peninsula, creating the artificial rains to fight with the forest fires.
And they also had success in doing that?
Yes, there are some such statistical results showing the decrease of the forest fires during the period of the activity. You may have something like 20–30% increase of precipitation. It's not that you create the heavy rains, you see, but you can increase the in essential manner the number of the water precipitated.
Maybe just to step back also, you had said early on that this is very similar to what occurs naturally with the radiation coming in from the galactic system. And I think maybe we could take a few minutes to discuss that, because that is kind of a relatively new area of study where we're starting to learn and understand that the effects of what the sun is doing, then also the effects of the high energy radiation from the galaxy are actually a constant input shaping the environment of the atmosphere, affecting climate, weather, affecting how water moves through the water cycle. You had said that the basis of these ionization technologies is actually acting on a very similar area as the ionizing effects of the galaxy. Can you say more about that?
Yes. Any energetic particle with energy higher than the ionization energy of ionization of molecules of air, which is from 10 to 15 electron volts. So any particles which have energy higher than this energy can ionize the water molecule. If we speaking in the on the cosmic sources of ionization, we have two main sources. This is our star, sun, and the galactic cosmic rays, which have much more higher energy. And the altitude of penetration of these particles into the atmosphere depends on the energy of particles. The solar particles have lower energy, so they cannot actually penetrate to the lower layers of atmosphere, and they lose their energy at the altitudes, say from several tens to 100 kilometers. So this is a source of northern lights, because they excite the molecules and atoms. Actually, in these altitudes, we are now speaking about atoms of oxygen and nitrogen, and we see the green and red lines of the polar lights. But the galactic cosmic rays, which have much more higher energy, decay at the, they have the peak, altitude peak, where they lost the main energy on the altitude of the tropopause. This is from 10 to 15 kilometers. This is the altitudes of the top of the clouds of our atmosphere. So these are the layers of where the clouds are formed. And the first good statistical results were made by Svensmark. It is Danish scientists who showed the fourth period, something like 2 cycles of solar activity, 22 years. The cross-correlation coefficient near 95% between the variations of the galactic cosmic rays fluxes and cloud coverage of our planet. And now this theory is developed very well, showing how the formed are primary ions, then they enter into the chemical reaction, create the final ions, and these final ions became to be hydrated and form the nucleus clouds. So this theory is well developed, and probably you have heard the huge, you can say, camera created in CERN in Switzerland, where they study this process of the cloud formation. But they spent a lot of money, and I prefer the experiment of Japanese, which is very simple but very clever, showing this process very clear.
Hmm.
So, and what is very interesting, that sometimes physicists who are working in this field do not take into account another effect connected with the ionization. It is the release of latent heat. You know that the water molecules free in the air, which in air exists as a gas, and water molecule in water have different energy. And this difference between free, so we say that water can exist in three phases. It is gas, liquid, and solid. So water vapor, water as we drink, and ice. And between them, there is a difference in energy of water molecules, which we do not see. That's why we call it latent heat. So, for example, to evaporate, you know, this is a proverb that watched pot will never boil. Because it seems you reached 100-degree temperature, but you wait and wait and wait until the vapor starts to be emitted from the water. This is the period when the water molecules gain this latent heat to evaporate, to become free from water. And we have backward process. When the water is condensed, it releases the heat into the environment. So that's why in the Asian countries we see a lot of fountains, and probably you have also in California the special water systems, because water from fountains starts to evaporate, and it absorbs the heat and decreases the temperature in this area. That's why we create the fountains. To decrease a little bit the temperature where we have hot climate. So, if we deal with the ionization, we have the same effect. When the ions are when the water condenses on ions, it releases the heat. But if you decrease the condensation, you will decrease the temperature in this place. That's why it was discovered the connection of the sharp decrease of galactic cosmic rays fluxes during the magnetic storms with formation of the hurricanes. Again, in Mexico, I have a good colleague, Jorge Perez Peraza, who is working on the connection of the fluxes of galactic cosmic rays and formation of the hurricanes in Atlantic and Pacific Mexico area, and he has very good statistics showing that when you have a lot of Forbes decrease, so active sun, many magnetic storms, this increase the probability of formation of the tropical cyclones and hurricanes. Because, and we published the paper showing the physical mechanism. If you have decrease of the fluxes of galactic cosmic rays, you decrease the temperature on the level of tropopause, and in such a way you increase the temperature difference between the surface of the ocean and tropopause. So you sharply increase convection and help to hurricanes to form due to increased convection.
I think this is a kind of remarkable thing you're saying, is that these high energy particles not coming from our Earth, not coming from our star, coming from all regions of the interstellar space and the galaxy, are actually playing an active role in things like the strength of hurricanes or hurricane formation.
Yes. And there was discovered another effect of modulation of fluxes of galactic cosmic rays with periods of glaciers, ice ages, in long-term history of our planet. And they were able to demonstrate that it could be, this hypothesis could be connected with movement of the solar system in the arms of our spiral galactic. And when solar system is inside the arm, there is more dust, so the less flux of the galactic cosmic rays. And between the arms, we have the larger fluxes of the galactic cosmic rays. And these periods coincide temporarily with periods of increase and decrease temperature of our planet.
All these ionization effects, these cosmic radiation effects that you're describing here, that they're constantly creating certain conditions in our atmosphere that affect how water vapor behaves, that affect how weather behaves, that affect climate.
Yes, and we should not forget that more clouds, you can have the shadow on the Earth. So the temperature variation is connected not only with the direct heat created by cosmic rays, but with the shadow. More clouds, more shadow. Less clouds, you are open to the sun. So these variations of temperature connected with shadow are also essential.
I just have to say, this kind of redefines what we should mean when we think of the Earth's climate, because it's not, it's more like a solar and galactic climate than just an Earth climate.
We should take into account both of them. You see, we cannot say that it is only galactic, but galaxy creates some contribution to the variations of climate in our planet.
And so you're saying that this work being done with these ionization systems is a way that we can begin to affect these types of parameters and create our own influence on these weather systems, the water cycle, and utilize that to our own benefit.
Yes, I think so. It is possible, but we should do it very, very carefully. I suppose that there should be state or administrative control of such kind of, because influence on the environment could be dangerous. You should have some limits, because you can create huge installation to make very large ionization, depending on the polarity which you put on the antenna, you can increase the number of clouds or decrease the number of clouds. Somebody will want to have a resort, have a lot of sun. Another one wants to produce grapes and have rains, and they could be neighbors and fight what you have to have clouds or don't have clouds. So it should be this activity should be regulated, of course.
Well, what would you think should be the next step for developing these systems in a as you're saying, in a mature and regulated way? Because I think this opens up a whole new potential, obviously, for how mankind can deal with these challenges like droughts or like bad weather occurring that causes excess flooding. This is a growing major issue. Water is a huge issue, not just for the United States, but globally. There's many places in the world that are lacking fresh water, or they lack regular supplies. They get rain, and they get drought, they get a little bit of rain again and drought. It seems like what you're defining here is a incredibly important perspective for how we could begin to, in a responsible, regulated way, we could begin to manage water in a completely new way by managing how it operates in the atmosphere, not just how it operates once it lands on ground. So from your standpoint, what do you think would be the next steps to begin to develop this in a responsible manner?
I suppose we should organize the open and clear distinct experiments on this with good scientific support. The scientists to be able to control and to see that such kind of effects really exist, because let's say traditional atmospheric scientists or meteorologists sometimes say that possible. So we should at least make this experiment to demonstrate it to first to the scientific community, and second to the public, that there's no danger in this. These effects are not more dangerous than natural electric field. I know that in some experiments in Mexico, the cows came closer to this installation because they have a better feeling inside this electric field. So this is a proof that it is not a danger for nature and for birds. Birds feel very well the electric field, so they will not approach to this installation.
And maybe also, we've been mostly discussing the activity that went on in Mexico, but there are other companies and other places where these systems have been demonstrated. Isn't that correct?
Yes, I know that such companies exist in Saudi Arabia, probably in Australia, maybe somewhere in Russia, but they are not doing active experiments. I know that there were experiments on ionization in Japan during 5 years, but they were not connected with rains. They were connected with dispersing fogs in the mountain roads of Japan. So you create participation in the decrease the fog to improve the movement in tunnels and high mountains where the fog is formed very often.
Well, how long do you think it would take to get a demonstration system set up, say, to maybe in the region somewhere in California to demonstrate the validity of this technology?
Actually, to put the installation takes 1 to 2 weeks. And I suppose we need at least 1 year to check different seasons. You see winter, autumn, spring, summer, where we have the optimal conditions to create favorable conditions for this precipitation, and we should take into account also the plant calendar if we want to with farmers who need also the rains and so on, not only for drinking but for agriculture also. So, but it seems to me that 1 year will be enough for experiments.
Well, again, I mean, I think this is a very exciting and important perspective to be discussing, you know, in the context of the drought in California, the water needs of other places in the world, that there are these technologies, and as you're discussing, there is the theory behind these technologies which can enable mankind to begin to address these problems in a new way. So I think
we did not discuss this in this presentation because, okay, it should be presented at scientific conferences. I said only the general things, how it happens. But physics is not very complex, but at least you need to have some background to understand these processes.
And you have said that your work in studying earthquake precursors and how the lithosphere and the atmosphere and the ionosphere interact in the preparation process for earthquakes has the theoretical framework you've developed in studying that has very, very valid applications for this weather control as well.
Yes, because it is the same physical process and even the same environment, because the installation is near the ground. So we have only the different sources of ionization.
Well, I think this is a very exciting and important perspective that we're discussing here. And I also think just because we're speaking now from the United States to Russia, I think this is also an important area that we can have productive and healthy international collaboration in these areas.
And I suppose in conditions which we have today, it probably may help us to improve our relationships, which a little bit go down during the few months last year and this year. But
yeah,
this always our cooperation, for example, in space, in International Space Station, and in physics at all, was all the times not depending on any condition, was very firm, was very friendly. And I suppose we should maintain these relationships.
certainly seems like a key area because we're defining how mankind can address problems that are, bigger than any one nation. A drought's not just an issue for one part of the world and not the other. These are the types of things that all mankind should be thinking about.
Yes, of course, it is a global problem, and all nations should unite to improve living conditions.
Well, do you have anything else to add in conclusion? I really appreciate you taking the time to go through some of the science and your background in this area. I think it's very important.
And I also want to thank you that you find me and give me possibility to explain how we can fight with the droughts. We need too much money for this installation. It's not cheap.
Relatively cheap to do. It's not an incredibly expensive operation.
For example, in comparison with the seeding from airplanes, this order of magnitude is.
Uh-huh. Well, I thank you again for joining us, Professor Pulinets. Always a pleasure to get a chance to speak to you and get your understandings on these things.
Thank you, Ben, and welcome to visit us. If you will have such possibility.
I would be very happy to. Well, I thank you, and thank you for tuning in, and we will have more on this very important subject on larouchepack.com. Thank you for joining us.